Welcome to the lecture on classification of metalworking processes. So, we will now start discussing about the metalworking processes, different type of metalworking processes. We will analyze the mechanics of the processes and also different aspects related to different metalworking processes. So, what is the purpose of going for metalworking? That we are hopefully known to, that during casting basically you get the defects like blowholes, air inclusions or so many a times, or many a times you need to have specific properties. So, what you do is you work the metal. So, you work the metal for controlling some of its mechanical properties, for imparting certain mechanical properties which you specially desire to have. So, that is why these metalworking operations are important. So, basically metalworking processes, when the term is used, it means that you are giving a particular shape, different types of shapes can be obtained using the plastic forming processes. So, you have those forming processes which results into plastic deformation. So, we know, we have studied about the strains, stresses generated, and we know that when we talk about the plastic deformation, we talk about the true stresses, true strains, more specifically for the analysis of the processes or finding the stresses. So, basically the meaning is that for controlling the mechanical properties, we use these plastic forming processes. So, this way you have improved properties, like many cases your impurities are gone, especially the shrinkage defect, gaseous defects or blowholes or the air inclusions which are there inside, they are welded. So, this type of properties are improved. Many a times the strength is improved, ductility is improved, fracture toughness is improved. So, all these properties are improved, and basically only for improving the property we go for metalworking, and also for shaping in certain cases. So, for that also you go for, but during that process the mechanical properties usually improves. So, in many ways. So, the process are basically classified on different basis, like the different types of forces applied, like sometimes you apply the compressive forces, you apply the compressive forces or the tensile forces also, and so type of forces and bending forces or so. So, different types of forces which are applied. Then the temperature at which the working has to take place. So, the temperature basically, if it is higher temperature, then it is known as hot working, or if it is lower, then it is known as cold working, and if it is in between, then it is known as warm working. So, which temperature means, normally it is the recrystallization temperature, which defines all these ranges. So, if the working is done above the recrystallization temperature, you call it as the hot working processes. If it is done below the recrystallization temperature, then we call it as the cold working processes, and if it is in between, then you call it as warm working, where you have the benefits of both hot and cold working. So, we will discuss about the different aspects of these different bases on which the different types of metalworking processes are defined. Then you have the cases, you can also define that in certain cases you have strain hardening taking place, in certain cases you do not have strain hardening taking place. So, that is basically in hot and cold working. In hot working the strain hardening does not take place, whereas in cold working the strain hardening takes place. So, this way you can classify the metalworking processes in different way, you can categorize them, and we will discuss one by one. So, first of all, depending upon the type of forces which is applied, now the type of forces based on that which is applied, you have the direct compression type forces. So, if you have the direct compression type forces, means the compressive stress, compressive force is directly applied to the surface of the body, and in that basically the metal will flow at right angles to the direction of compression. So, basically you have a job and you apply the compressive stress, compressive forces from the top and bottom both, so that the direction of compressive forces are suppose in vertical direction. So, metal will flow in the horizontal direction. So, that is the so that way we basically define these direct compression type of forces. So, the examples for these direct compression type of direct compression type processes where you use the direct compression forces, they are basically forging and rolling. So, you must be conversant with the process of forging and rolling. So, if you look at, so you have the direct compression type processes, so in that you have forging or rolling. Okay. So, in forging what we do, you have a die and you have a workpiece. So, you have two dies and then you apply the direct compression on this workpiece. So, your forces are applied in this case, and then the metal which is here, it experiences the compressive forces from both the directions, and then it flows in this as well as in this direction. So, it flows and in the direction perpendicular to the direction of the force. So, this way these are the processes. So, forging and rolling are the examples of such type of direct compression type of forces. Then you have the indirect compression type forces. Now, what happens in direct compression type of forces? The examples are like wire drawing, tube drawing, rod drawing or so. So, these are the types of examples of indirect compression type of processes. So, basically in these cases the primary applied forces are normally tensile, but the indirect compressive type of forces, they are developed because of the reaction of workpiece with the die, and that reaches very high values. So, that's why it is known as indirect compression type, because you apply primarily the tensile type of forces, but then the compressive stresses which are developed at the die and the job interface there. So, it gives the stress value which is quite higher, and then material plastically flows. So, basically because of this reaction, you have a complex state of stress acting in such cases, and then you have basically quite a high value of compressive stress in one of the principal directions. So, because of that you have the flow of material in those directions. So, basically you have the examples like wire drawing, or you have the extrusion, or you have deep drawing. These are the examples of these direct compression type, indirect compression type of processes. So, you have indirect compression type processes. So, in that, suppose what you do is, if you take the example of wire drawing, what you see is that you have the rod of larger diameter on this side, and from this side you basically open it, and then you have a die, conical die, which is stopping it, which is basically giving the constraint it to flow through a very small orifice. So that way this wire is drawn. So basically you are applying directly, primarily the tensile force, but then at this point where it wants to come out, at there, because of the reaction, you have the compressive stresses reached, and at that point you have the complex state of stress. So because of that, basically so basically what happens, you have such type of in the case of wire drawing. So you have here you are basically what you do is you apply this tensile forces, and then you are basically, once you apply the tensile forces, in that case here, because of this constraint, these indirect compressive stresses are developed at this interface, and that is how they result into this smaller wire diameter. So this is known as wire drawing. Similarly, you must have seen the process of extrusion. In the process of extrusion, what you do is you apply the force, and then it goes out, but then there is compressive stresses developed on the sides. So this way, because of that compressive state of stress, as well as you are applying the force, so there is tensile stresses developed, tensile forces developed at the exit. Then because of these combined or complex state of stresses, the material flows through the die opening. So that is known as extrusion. Similarly, you have, so here in that case you have wire drawing, extrusion, bending. These are the example of these indirect compression type processes. Similarly, you have bending. So what you see in bending, so you have basically the no, this is not bending. Basically you have this deep drawing, not bending. Bending, you have a separate kind of separate classification. So you have the deep drawing. So in the deep drawing, what you see is that you have a cup shaped product you are making by deep drawing, but then in that case the height up to which you are basically going for, that is larger. So you apply the forces in that case, and then at these from both these sides basically. So what happens? So you have like this. So this height becomes quite larger, and what you do is you apply the forces, and then the reaction forces develop on the sides. So here basically you are giving some constraint, you are having some here also some weight and also. So what happens, you have stresses which are generated here. So because of that the material flows. So here you have plastic deformation taking place, and then metal takes this shape under the application of this force. So this type of methods, because you are applying one force here, in this direction it goes. So they are the examples of indirect compression type forces. Then the next kind of processes are the tension type of processes. So you apply the tensile forces basically, and here the example is stretch forming. So basically what you do is that you have a form block, you put the sheet, and then you apply this tensile force from both the sides. So what happens, because of the tensile forces, so you have suppose a form block. So like that you have the form block, and then your sheet will be like this. So your sheet will be like this, and then you apply the forces like this. So once you apply the forces, so you have this as the, so it will go like this, and then you apply these forces, and then so this way it stretches. So basically this stretch forming, this is known as a stretch forming. So basically depending upon this the shape of the form block or the die, you can say here, in this case this is a die. When we use this in the case of using the lathe or so, then we call it as the form block. But then this is a die, so you are giving that sheet and then you are applying these tensile forces from both the sides, and basically depending upon the shape that will be stretched on both the sides, that is known as stretch forming. So this is the use of the tension type processes. So this is under tension type processes. So in that your this process comes out. Now you have the next example is bending. Now in the bending, basically this involves the application of bending moments onto the sheet. So you have the sheet and you apply the bending moment so that it comes and takes the so bends from both the directions. So that way you get a bent specimen. So you have a specimen like this. So before that you have a tool, and then this tool has such shape, and then it applies the pressure in this direction. So once it applies the pressure in this direction, you see that you have the forces or stresses acting, and that and under the action of these stresses basically, so it will do like this, and then you will get to see that it takes into this form. So this is the application of bending process. Then next is the shearing process. Now in the case of shearing process, what we do is you have the shearing action taking place. So you will have on one side you have, so normally you have a plate which is to be sheared, then you have a blade from the top and from the bottom, and then because of the action of shear forces the plate is cut or so. So it will rupture the metal in the plane of shear. So that way it will the material will be ruptured and the shearing action takes place. So suppose you have the plate, so you have one and here, so one plane is here and another plane is here, so it will rupture this. So it will apply the pressure in this direction, it will apply the pressure in the opposite direction, and then it will do the shearing. So that way shear type of processes work. So this is shearing. So shear type processes. So shearing action takes place in those cases. So this is based on the different types of processes which are basically applied, and then you can see you have these different kinds of processes. Further, they can also be classified based on the primary and secondary metalworking processes. So many a times we call this term as primary metalworking processes, or we also call it as processing, and then you have the secondary metalworking processes which is known as fabrication. So basically when you are reducing the maximum of the deformation you are putting on the material, when you make the ingot and you have to further convert to slab or billets or so, then in that case the deformation rate is quite high. At that time your primary aim is to deform, to give large and large reduction to the dimension of the specimen. So basically, and then you are basically converting to simple shapes like plates, bars or so. So, that kind of processes are known as the primary metalworking processes, and when we talk about giving the final shape or finishing, then that is known as the secondary metalworking processes. So, basically all your so that is also known as fabrication. So, all the sheet metal operations, they come under such cases, wire drawing or tube drawing. These are basically the secondary metalworking processes, where basically those processes are done after the primary operations are done. So, that is for final getting the final product, finally finished product is used. So, that is known as secondary metalworking processes. Now, another classification which is done for the metalworking processes, as we discussed, that it may be based on the temperature. So, based on temperature, we normally categorize them as either hot working or cold working. So, based on temperature, so you have hot working and cold working. Now, there is basic difference between these two. The hot working refers to those processes where the working is carried out at a temperature which is above the recrystallization temperature. So, in this case, the degree of deformation possible is more, because as the temperature is more, less flow stress is required to do the deformation, plastic deformation. So, in that case, because the essential difference between these two is that in this case of hot working, the recovery takes place simultaneously. So, material does not strain harden, and that is why you do not require, as long as the temperature is above the recrystallization temperature, the flow stress requirement is not very high. So, this is the basic trait of the hot working processes, and all the primary working processes which we discussed, where we intend to bring initially the material to a simple shape or the degree of deformation is somewhat larger. In those cases, the hot working is preferred, and depending upon the type of process you apply, I mean type of specific processes, like if the forging is done at a temperature above the recrystallization temperature, then it is hot forging. Similarly, if it is done below the recrystallization temperature, it is known as cold forging. Now, this temperature, what is the recrystallization temperature? This temperature is somewhere close to 0.5 to 6 or 0.7 multiplied by the melting temperature of the body, so the material. So, that will be normally the hot working. So, for certain materials, very high temperature may be the hot working. So, for certain materials like tungsten, which has very high melting point, very large will be the hot working temperature range, whereas for certain materials even the room at room temperature or somewhat only some high temperature may be the condition for hot working. So, like that. So, it depends upon the melting temperature of the material. In the cold working, what happens that if the temperature is less, it is done normally for the finishing operations and also giving the strength. So, in these cases, what happens, the material is deformed and the plastic deformation takes place, and during that basically the strain hardening takes place. So, as the strain hardening takes place slowly, the flow stress requirement for the further reduction in the cross section is increasing continuously. So, that is why there will be a limiting extent, there will be a limit up to which you can cold work the material. So, after that when the stress value reaches quite high, then material may fail if you are still try to cold work. So, there is basically a limit up to which, so that is why when we have to see the cases where you have not to deform the material to higher degree of reduction, in those cases the cold working has to be done. Also the temperature will tell that whether it is to be hot worked or cold worked. So, for the material which is ductile, you can be hot worked, or it can be worked even at lower temperature. But then even as we discussed that many a times the temperature also tells that there will be a temperature at which some even better materials will try to behave as the soft materials or ductile materials only because of the temperature. So that's the different aspect. But then there are other aspects of hot working and cold working, that in the hot working the challenge is to have the surface finish. So because you have the working at a very high temperature, so there are oxide formation at the surface, because at the high temperature you have quite high reactivity. So you have the chances of oxide formation at the surface. But then in that case that problem is not there in the case of cold working. So this is how they are basically categorized. Then again based on the strain rate. So you may have the strain rate, you have sometimes very large at very large velocity the working goes on. So that way ram velocity will be quite larger. So you have normal processes which some processes with like HERF is there where very high at very high velocity this very rate the deformation takes place. So that also is one of the parameter that basically classifies the different types of metalworking processes. Now the thing is that when we talk about these processes, then we are basically thinking of a zone in which basically this deformation takes place. So when the deformation has to take place, you have to see that there should not be local fracture or something. At certain condition you will have the failure starts or the deformation starts. So you may have specific conditions, but then there are certain things which need to be seen. And now we are focusing basically on the zone where the deformation takes place. So that is how you have a deformation zone. So when the force is applied by the dies on the surface of the material, in that case what happens, you have a zone which is in contact with the die. Now what happens that you have the die which applies the pressure on the job. So if you look at a typical deformation process, so suppose you have a similar type of such type of die. Now in this case if you have so you have suppose one this and which goes like this. Now suppose in this case here you have one envelope forming, and then you have these are the dies which apply the pressure, and this is going. Now this zone which is there, which is in between the die, this is known as the deformation zone. Now what is this deformation zone? The zone where this deformation processes take place, where the deformation process takes place, that is basically the deformation zone. You have this area as the where the lubrication takes place, and there will be movement of the this take place. So you have this as lubrication system. So you have the because there must be, so you will have the friction acting there, and then that basically will assist. So even friction also which acts here, that also helps in getting the deformation here. Here you will have the frictional forces because of which this will go into this cavity. So this is the basically principle of some of the operations like rolling operations. Now from this side, this is your undeformed material, and then after deformation, this is the deformation zone, and then this is the deformed material which is going out. So basically these are known as the deformation zone. Now you have friction acting there, in this system. You have the tool and die. So what happens? We must know that what is this deformation zone, and you have to view the whole system as the total system. So coming to this point where we see that you have the, as we discussed, that you have many parameters which talk about which must be kept in mind while discussing about these situations, like you have the strain rate, you have basically the distribution of stresses. All these are important to see that how the process is performed. So that's what about these deformation processing of this particular. So this map which talks about that tells like deformation processing. So this when we talk about all these aspects into account, and we have the graph, we have the picture of all the things, the effect of all the parameters in a well organized manner, then they are known as deformation processing. So this process is known as deformation processing. So in that, basically it is assumed, or it is thought to be useful that the stresses should not create any local yielding. Okay. So we assume that the stresses must not create any local yielding. Yielding has to take place, but then local yielding should not be there, and the strain hardening and recrystallization and fracture, these are the important part of this deformation processing, but then they are basically discussed when you have specialized condition of high strain rate and or high temperature. So what happens that the workpiece is basically in contact with these non-deforming tools. As we see, you have these tools. These are the tools. So these tools are in contact with, the workpiece is in contact with these tools which are non-deformable. So a lot of things are going on at this interface. You have heat transfer going on, you have friction which is working. Okay. So all these are to be basically understood, and what is the mechanism, so to understand the whole process. So this is basically known as deformation processing. When we discuss about this, basically as a whole we call as deformation processing. So you have the deformation processing maps, different types of graphs, different types of parametric analysis and all that. So they are known as deformation processing maps or so. So this is all about the classification of metalworking processes. Thank you very much.